Hi everyone. Okay, so we're going to be starting chapter 5, and in chapter 5 there's a few things that we need to know and get some vocab out of the way. And here's a couple, like here where you have to classify triangles by their sides or their side lengths. So you have to determine whether a triangle is scalene, isosceles, or equilateral. And there's also a way to classify triangles based on their angles, where they could be acute, right, obtuse, or equiangular triangles. So you can go to your online textbook where you could actually go to the login page where you type in your information. And I want you to go to the Student Dynamic ebook and you click on that. And when you do that, you need to get to chapter 5, section 1. And if you notice in here that there was already some notes taken in the same format that's on your worksheet. So basically, I just want you to copy it, but I also want you to know that there are also video links that you can check, such as in this example. They're talking about classify the triangle shape of the support beams in the diagram by its sides and by measuring its angles. So you can click on that video and the video will start.
Classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. To classify a triangle by its sides, you first need to determine the number of congruent sides. In the given diagram, there are no tick marks to indicate that any of the sides are congruent. So, there are no congruent sides. Therefore, because there are no congruent sides, this triangle is a scalene triangle. Next, to classify a triangle by its angles, you first need to measure its angles. One of the angles in the given triangle is marked with a right angle symbol. So, this triangle has one right angle with a measure of 90 degrees. Next, when you measure the bottom angle in the triangle, you find that its measure is 30.
Now, you can watch the whole video, but you're not going to need to measure the angles. Actually, all you really didn't need to know that it's a right triangle and it's scalene. So knowing that information, you can continue on.
35 degrees. Finally, when you measure the third angle in the triangle, you find that its measure is 55 degrees. Now, this triangle has one right angle and two acute angles. So, because it has one right angle, this triangle is a right triangle. Therefore, you can classify this triangle as a scalene right triangle.
Okay, so that was one video. You could keep going and classify and look at some of the other stuff. Also, some of the notes. Go to the next page. Now, this is something we did before, where you classify the triangle in the coordinate plane, and you'd have to use a distance formula. And here's a stepped out solutions of how to do it in this example. And again, there was another video. As you go, there are a few more videos, and we get to the next part here with our vocabulary. And you notice that there's interior angles of a triangle and exterior angles of a triangle. One thing I do want you to be aware of is when we think about exterior angles, it's a little different than what we're used to thinking when you think of exterior. So make sure you understand. The next part is, well, the triangle sum theorem. And this one basically says that a triangle's angles sum to 180 degrees. So angle A, angle B, and angle C, when you sum their measures, will equal 180 degrees. And we actually did a proof of this on one of our worksheets. You could actually check your proof lists, your reasons list, and take a look at the proof. But in the textbook, it also has the proof itself, an example of it. The next thing is when after you look at this proof theorem of the triangles interior angles, you could actually use it to prove the next theorem, which talks about exterior angles of a triangle theorem. And if you look, there's an angle here in red that's labeled angle 1. And in this, they're saying that that angle 1 is an exterior angle, and that whatever it measures equal, it's the sum of angle A and the sum of angle A and B. Okay, and in fact, when you go back to the textbook, you kind of play around with this. If you go back to, I believe, 231, There's a nice little link here where you can click on, and it'll load up a little interactive GeoGebra page. And if you notice, you can kind of click on any of these pages, any of these buttons, excuse me, and over here, if you notice all the way to the right, it takes the measures. And if you take angle A and angle B and you sum them, you should get 118.03 degrees. So you can move it around and notice that no matter what kind of triangle you have, whether it's acute isosceles, if you could try, or obtuse, that'll work. And if you go up here, it says something here, it says drag me. Click on that and move it, and notice it's like a nice little way of seeing the theorem in action, where these two angles, the angle A, which is in red, and angle B, which is in green, when you move them without changing their measures, it is the measure of angle ACT, which is pretty cool. Now, when you go to the worksheet, I want you to make sure that you fill out the notes as best you can. And as you go through it, make sure you understand what an interior angle of a triangle is, exterior angle of a triangle, as well as what a corollary theorem is. As you go through, there are spaces for you to fill in your own notes. Make sure you write the theorem, and in this example, you might want to copy it where it says angle A plus angle B plus angle C equals 180 degrees. So we wrote this in algebraically here, but I want you to write it in everyday language over here, where you'd say the sum of the interior angles of a triangle is equal to 180 degrees. Okay, and so write that out. Maybe you put a note in the day that we actually did the proof for this. You'll have to look at your reasons list that we created, and we actually put a date on the reason for triangles, angles, sum to 180 degrees. So take a look at that. And then we have another theorem here. That's a new one, so I need you to make sure you record it correctly, similar to the way we did it up here. And here is another one, a corollary to the triangle sum theorem. Make sure you have that. When you're done, look at the example problems that you will see. Okay? Well, see you tomorrow in class.